Hey there, aviation enthusiasts. We're excited to bring you our latest creation for MSFS2020, the legendary MiG-25. In this video, we'll give you a quick tour of this iconic aircraft and show you how to master it in the sim. Let's dive in and take this beast to the skies. The MiG-25 is a Soviet supersonic high-altitude interceptor and reconnaissance aircraft, developed by the Mikoyan Design Bureau in the 1960s. This aircraft was a Cold War superstar. It can reach speeds of up to Mach 3 and altitudes over 65,000 feet, making it one of the fastest combat aircraft in history. The MiG-25 had many different modifications, and we based our model on its most common variant, the PD, which translates from Russian as Long-Range Interceptor. As you approach the MiG-25, its sleek, angular design immediately stands out, built for pure speed and altitude. Despite its seemingly modest size, this aircraft is quite massive, with a length of about 74 feet and a wingspan of 46 feet. Making it larger than the F-15, but significantly heavier. The MiG-25 has a maximum takeoff weight of around 98,000 pounds, compared to the F-15 as approximately 68,000 pounds. The twin RD-15B-300 afterburning turbojet engines, designed by the Tumansky Design Bureau, each produce a thrust of around 27,500 pounds, giving the MiG-25 its incredible Mach 3 capability. Up front, the sharply pointed nose houses advanced radar systems, perfect for high-altitude interceptions. And those massive, distinctive square air intakes. They're designed to gulp in air at supersonic speeds, making this jet a true powerhouse of the skies. Now let's take a look inside the cockpit. This is a typical cockpit layout for aircraft designed by the Mikoyan-Gurevich Bureau in the 1960s. Let's quickly go over the main instruments. On the central panel, within the white frame, you'll find the primary flight instruments, the Command Flight Instrument, KPP, the Navigation and Flight Instrument, NPP, Vertical Speed Indicator, VSI, Airspeed Indicator, and altimeter. On the left side, we've got the weapons control panel and stores management switches, the true airspeed and Mach number indicator, the radio altimeter, backup altimeter. Here is the air intake control instrument, the DME counter, and the warning lights panel. Below that is the Autopilot control panel. This is the radar control panel, and here's the radar sight. These are the hydraulic pressure indicators, voltmeter, and similar gauges. On the right side, there's a combined instrument showing allowable G-forces and angles of attack. These are the navigation control switches. This instrument shows the engine RPM, with two needles for the right and left engines. This gauge displays the exhaust gas temperature. Below that, we have the combined fuel gauge and fuel flow meter. The right-hand panel houses the radio navigation equipment. This is the RSBN Short-Range Radio Navigation System Control Panel. This is the ADF Automatic Direction Finder Radio. In Russian, it's called ARK. And here are COM1 and COM2 radios, and radio channel knobs. This is the Cockpit Lighting Control Panel. Below that, you'll find the IFF Transponder Control Panel, Friend or Foe System, and the Ground Guidance System panel. The MiG-25 could be guided automatically from the ground without pilot input. This panel is part of the Autopilot system, where you can set climb modes. This is the self-destruct panel for sensitive equipment. Here's the main electrical control panel. The switches are color-coded, orange for power sources, batteries, generators, etc. White and black for primary systems, radio equipment, etc. Red for the autopilot. Yellow color switches are related to engine control. This is the circuit breaker panel. All breakers should be turned on before starting up. This instrument is for decoding radio channels and all control signals. By clicking this icon, we can swap it for standard avionics for those who don't want to deal with the vintage equipment. To the left, there's a standard transponder. Here is the engine start panel and the system pre-flight checks. This is the exterior lighting switch. Here is the control panel for the Automatic Flight Surfaces Control, ARU, along with controls for other automatic systems. These are the oxygen valves and the controls for the pressure suit ventilation system. This large handle is the radar joystick, currently non-functional. And these are the throttle levers. This is the control panel for deploying the drag chute. Here's the manual automatic switch, and this is the button for deploying the chute. This switch controls automatic braking on landing. The engine control panel is next. And by the way, all yellow switches are related to engine management. These two switches deactivate maximum afterburner. The afterburner has two levels, basic and maximum. These are the oxygen sensors. This is the fire control panel. Here's the landing gear lever and the indicator panel for the landing gear, flaps, and air brake deployment. These two buttons control flap extension and retraction. The MiG-25 has only two positions for the flaps, deployed or retracted. This is the parking brake lever. These are the levers for sealing and closing the cockpit canopy. For convenience, they work automatically. Just click in this area to open the canopy. Now, let's move on to the engine startup procedure. I'll walk you through a simplified engine start. First, we turn on the circuit breakers for all electrical systems. These are all the switches that need to be set to the upper position. Next, we switch on the battery power, AC and DC generators for both engines, and the start units. On the engine control panel, all the yellow switches should be in the upper position. This includes the fuel pump switches and the full afterburner switches for both engines. The air intake and nozzle control systems also need to be enabled. On the start panel, we activate the bypass valves for the second compressor stage and both engine start units. These two switches need to be in the upper position, start mode. Move the left throttle lever to the idle position. Press the left engine start button under the safety cover. Monitor the engine RPM increase on the tachometer. At around 20% RPM, ignition occurs. Once the engine reaches 50% RPM, we can proceed with starting the right engine. Move the right throttle to idle. Activate the cross start switch and press the right engine start button. While the right engine spools up to nominal RPM, switch on all electrical systems. Radio equipment, COM1 and COM2, navigation radio, RSBN, ADF radio, and the rest of the systems. You can see the gyroscope spinning up. Turn on the autopilot power. It's important to synchronize the gyroscopic compass with the magnetic heading. To do this, press the sync button. Check to make sure that the warning and error lights are off. You can now turn off the start units. Also, don't forget to switch on the navigation lights. As you can see, the startup procedure isn't difficult, but if you don't want to go through all the steps manually, you can do it automatically. On the front panel, there are 3 menu buttons. Go into the state settings, and you can set the aircraft state to either cold and dark or ready to taxi. You can also switch all the light panel's text to English here. The next menu is the loadout panel. Since we're going on a long flight, we'll be adding an external fuel tank. To load weapons, you'll need to install the weapons module into the community version. This module can be downloaded from our website. Click the Full Refuel button. Before takeoff, we need to set the fuel gauge readings. This is usually done manually, but by right-clicking, you can do it automatically. Let's start by setting up our flight plan. This will come in handy when using the RSBN navigation system and Autopilot. Since we've chosen the Ukrainian camouflage, we'll be making a high-altitude flight from Kyiv to Frankfurt. Fuel consumption varies greatly depending on speed and altitude, but I believe we'll have enough fuel to reach Frankfurt and Maine. We'll be flying using VOR to VOR navigation. Need to remove unnecessary waypoints from the route and prepare for takeoff. Next, we need to refine the flight plan. In this menu, you can see the flight plan that we set up on the map in the main menu. These columns correspond to the Nav1 and Nav2 channels. This block is related to both comm radios. This column shows the ADF frequencies. You can see the ECAL code of each waypoint, the frequency, the heading to the waypoint, and the runway identifier if it's an airfield. This column corresponds to the preset buttons on the RSBN control panel. We'll get to that next. The flight plan was automatically generated, but all the values can be edited, or you can create a custom plan manually. For the VOR to VOR route, we'll be using the RSBN short-range navigation system, and this is the RSBN control panel. The top row of buttons are the airfield presets that are set in the flight plan. In this case, we have 2 airfields linked to the first and second buttons. You can see this on this small board. The second row of buttons are the VOR waypoint presets. The board only shows the first 3 waypoints. In real-world operations, that's usually enough for a combat mission, but if needed, we can use the airfield buttons as additional waypoints by pressing this special RO button. It's similar to the functional key. This button resets all modes. This button is for returning to base mode. I'll explain the rest of the RSBN panel functions during the flight. We're almost ready for taxiing. Let's request taxi clearance and takeoff. We can use the preset comm radio frequencies and switch between channels like this. Or we can do it automatically, just set the channel to 0.
Morris Pole clearance delivery MiG, Mike India Golf, 25 IFR to Frankfurt, ready to copy.
MiG Mike India Golf 25 is cleared to Frankfurt Airport as filed.
Turn on the taxi lights.
Takeoff runway 18 left climb and maintain 8,000 feet.
Deploy the flaps.
Launcher frequency is 135 decimal for 5 squawk 4236.
And start the flight timer. Activate the autopilot damping mode.
Morris Pole ground
Engage the steering wheel, release the parking brake, and taxi to the pre-start position.
Taxiing, hold short runway 18 left using taxiway Alpha Papa Romeo Oscar November Delta Charlie 5 Bravo Alpha 1 MiG Golf 25. Tower MiG Mike India Golf 25 ready for departure runway 18 left IFR to Frankfurt.
MiG Mike India Golf 25 QNH 29er decimal 9er 2 and 262 and 4. Cleared for takeoff runway 18 left.
Takeoff clearance granted. Taxi to the runway.
Takeoff runway 18 left MiG Mike India Golf 25.
Turn on the landing lights. The classic MiG-25 takeoff technique looks like this. Disengage the steering wheel. Set full throttle. Engage the full afterburner. Release the brakes. Begin the run-up. Hold the control stick back fully and wait for the nose wheel to lift off the runway. This will happen at around 250 minus 280 km per hour. After the nose wheel lifts, push the stick forward slightly and hold the pitch at about 8 degrees and wait for liftoff at around 300 to 320 kilometers per hour. We're taking off with a heavy load, so liftoff will be slightly delayed. Retract the landing gear. Retract the flaps once the speed reaches 400 kilometers per hour. Turn off the landing lights. Switch to the down position. Takeoff complete. Climbing out. Now, let's talk about the Automatic Flight Control System, or CAU in Russian. This is the Autopilot control panel. This button activates the Autopilot. When activated, the pitch and roll stabilization modes are enabled. Now we can set the pitch and roll using the control stick, and once you release it, the Autopilot will maintain the set angles as long as the speed allows. Here, we're making a turn in stabilization mode. This button on the control stick engages the wing leveling mode. Press it and watch as the aircraft smoothly levels out into horizontal flight. There's a duplicate of this button can be found on the front panel. Once the level flight is established, the light goes out and the Autopilot switches to stabilization mode. Now, let's get back en route. We'll use the RSBN navigation system and Autopilot. On the RSBN panel, press the first button that corresponds to the first waypoint. Make sure the navigation system is set to RSBN. That's the upper position of the switch. The lower position is for navigation on a DF radio beacon. On the navigation display, you'll see the radial indicator pointing to the waypoint. We can set the OBS course using the knob to navigate to this waypoint, but we'll use this switch instead, which automatically inputs the course from the navigation system preset. On the range indicator, you'll see the distance to the first waypoint. It's about 300 kilometers. At this distance, the VOR signal isn't detected yet, so the onboard navigation computer guides the aircraft based on the coordinates of the waypoint and our current position. but once the VOR signal is picked up, the system will automatically switch to course correction mode based on the VOR beacon. We'll be alerted by this light indicator. Now we can activate the autopilot mode that will maintain navigation via the RSBN system. Press RSBN button on autopilot panel, and the aircraft will automatically follow the set course. Now it's time to climb to altitude. We're going to try to reach the very top, or as pilots say, the ceiling. That's 24 kilometers, or nearly 79,000 feet. We'll engage full afterburner and start climbing. I recommend climbing manually up to 40,000 feet, about 13 kilometers, at an indicated airspeed of no less than 800 kilometers per hour, and then switching to automatic mode. Climbing to 79,000 feet takes just over 8 minutes, but since we have an additional fuel tank, it will take a bit longer. This is the altitude setting panel for the autopilot. Set the altitude to 24 kilometers. And turn on the automatic climb mode. The autopilot will now maintain an effective climb rate and speed. From the fuel remaining, we can see that the external tank is empty. The drop tank is pretty big, it causing a lot of drag and slowing us down. So we have to jettize it. The drop tank jettison button is located on the front panel under a protective cover. I've mapped the external tank release to a smoke trigger hotkey. So with the cover open, we can release the drop tank with a hotkey from the external view. Continue climbing and gaining speed. While we're climbing to the ceiling, let's talk about these two instruments. This is the air intake control panel. The intakes usually operate automatically. The solid arrows show their current position. We can manually adjust their position using these control knobs. To do this, we should switch these switches to manual mode. In case of an emergency, these two switches will retract the intakes to their initial position. This is a similar indicator showing the current status of the automatic flight control system, ARU in Russian. Simply put, the higher the speed, the less the control surfaces deviate. You can also switch this system to manual control and adjust the surfaces using this switch. Under the front glare shield, there are additional sun shields that can be extended. At high altitudes, the sun is very bright, and the shields can be quite useful. We're approaching the first waypoint. The RSBN panel shows a red indicator indicating we're within 40 kilometers of the waypoint. Following standard procedures from the flight manual, we disable RSBN automatic navigation and continue climbing in stabilization mode. Monitor the range indicator to pass the waypoint. On the RSBN panel, select the next waypoint and activate RSBN navigation on the autopilot panel. The aircraft will begin to turn towards the second waypoint. approaching the second waypoint. Disable RSBN mode and wait for the transition to the third waypoint. Switch to the third waypoint. We're reaching the ceiling of 79,000 feet or 24 kilometers. At this altitude, air resistance is very low, and the aircraft quickly approaches its maximum speed of Mach 2.8. The instrument reads 2.85 Mach or 3,000 kilometers per hour true speed. It's time to make an announcement for the passengers. Ladies and gentlemen, welcome aboard Ukrainian Airlines. Our comfortable MiG-25 has reached a cruising altitude of 24 kilometers. We're traveling at Mach 3. The outside temperature is minus 67 degrees Celsius. Through the windows you can see that our planet is definitely spherical. The flight time to Frankfurt is 3 times faster than with any other airline. Thank you for choosing Ukrainian Airlines. The yellow indicator on the warning panel shows that the aircraft's skin is close to overheating. According to the operating manual, the aircraft can fly at maximum speed for no more than 5 minutes. To avoid overheating, we need to reduce speed below Mach 2.5. To reduce speed, switch the afterburner to the first state. These switches disable the maximum afterburner. Speed will slowly decrease. We're approaching the third waypoint. Turn off the autopilot navigation. To activate the fourth waypoint, press the function button on the RSBN panel along with the first airport button. Now switch to the navigation for the fourth waypoint. It's time to begin our descent. I want to note that descending takes more time than climbing, and at such high speeds, we might easily overshoot our destination. Turn off the afterburners. Set the altitude to 32,000 feet, or about 10 kilometers, and start the descent. We can speed up the descent. To do that, let's turn off the altitude auto mode and autopilot, and descend manually. Maintain a vertical speed of 25 to 30 meters per second. To keep the desired course, use the director bars. These yellow lines on the artificial horizon show the bank and pitch needed to stay on course. Our task is to keep the vertical bars centered in the aircraft emblem. approaching 10 kilometers altitude. The speed is reduced, so we can now switch the autopilot to automatic mode. Switch to the final waypoint and continue the descent. For an automatic landing at the destination airport, we need to enter the ILS frequencies and runway course. So let's go to the radio frequency settings menu. First, we should find the ILS frequency on the map. Enter the Frankfurt Airport submenu. Select the Runway 25 central frequency. Input the frequency, course, and runway values. Now, button 2 on the RSBN panel has all necessary data for approach and landing. If needed, we can also manually select ILS or VOR frequencies. Switch the landing selector to the upper position. Now we can select VOR and ILS channels with these two knobs. But these frequencies must also be pre-entered into the corresponding channels in the radio frequency menu. If you don't want to deal with this, switch to modern avionics. Set the channels to 0 and set the nav1 frequency in the usual way, like in a simple Cessna 172. In addition to RSBN, the MiG-25 can also navigate using the ADF system. To do this, enter the ADF beacon frequency and the corresponding channel lines. Let's find a suitable radio beacon ADF and enter its values into the ADF channels. Turn off the RSBN navigator. Switch the navigation selector to the lower ADF position. Turn on the required channel on the ADF control panel. The yellow arrow on the navigation instrument will now point to the ADF beacon. The closer you get to the beacon, the stronger the signal and the more accurately the arrow will point to it. We are approaching the final waypoint of our flight plan. Soon, we'll be at the glide slope entry point. Turn on the landing airport on the RSBN panel. We can press the reset button and then the second airport button. Descend to the glide slope entry altitude, which is between 2,800 to 3,200 feet. By maintaining altitude and course about 20 kilometers from the runway, the autopilot will automatically switch to landing mode. The key condition for this is correctly set at ILS frequency and landing course. The automatic landing light is on. If needed, we can manually engage this mode by pressing the button on the autopilot panel. The aircraft transitions to the glide slope descent. Reduce speed to 600–500 kilometers per hour. If speed is high, you can use the speed brakes, which deploy using standard hotkeys. Deploy the landing gear and flaps. This is the automatic brake parachute release switch. Let's go ahead and activate it. There is an automatic braking switch, but we won't use it right now. Turn on the landing lights. We're on course and on the glide slope. Ready for landing. We should keep speed around 380 kilometers per hour on approach. Landing speed is 280 to 300 kilometers per hour, depending on weight and weather conditions. At 30 meters altitude, turn off the autopilot and land manually. Landing. Apply manual braking. engage the nose gear steering, and taxi off the runway. In this video, we've covered the essential systems and navigation techniques for operating the MiG-25, from pre-flight preparations to high-altitude performance, and from manual control to autopilot navigation. You now have a strong foundation in flying this remarkable aircraft. Don't forget to check out our other products, including the iconic F-111 and the MiG-21, for even more aviation experiences. If you enjoyed this tutorial, please consider subscribing to the channel and giving this video a like. Best of luck on your flights, and goodbye.